Okay, so today we are talking about graphing other trigonometric functions. So remember, we went over sine, cosine so far. How does sine start on our graph?
0.
At the midline, right? Remember, we can shift up, we can shift down, right? So sine starts at the midline. How did cosine start?
At the maximum or minimum?
Yeah, on that amplitude, that maximum value or minimum value, once again, depending upon those negative amplitudes that are pop in there. Today we're going to do the other 4 trigonometric functions. Okay? What you have to realize is not much changes from the other ones, but the graphs look different. So, there's my markers. We're going to make some disasters on some graphs first. Okay? So, when I had y equals sine x, the basic sine function. Oh, sorry. Go down here. We had our midline at 0. Amplitude was 1 to -1. No phase shift, no vertical shift, right? Our period was 2 pi, correct? So our critical values are 2 pi divided by 4, so that's every pi halves. So I go pi halves, pi, 3 pi halves, and then 2 pi. And we remember we started at the 0, we went up, we went to a 0, we went down, we went to a 0, and this just continued on, so we had this nice curve that looked like this, right? Y equals cosecant x. What is the relationship between sine and cosecant?
Inverse.
Not inverse. Not opposite. Reciprocal. Okay. Opposite's negative. Inverse is sine inverse. That has its own special properties we'll talk about in a later section. Reciprocal. Okay, so we have the reciprocal. When sine is 0, what is the reciprocal of 0? Undefined. So this means cosecant starts with an undefined graph. So remember, when something's undefined, that was that vertical asymptote that we couldn't cross. Now, what's the reciprocal of 1? 1, so we see this point, it stays the same. Here at pi, we have the reciprocal of 0 once again, so we have that undefined line, that vertical asymptote. What's the reciprocal of -1?
-1.
-1. And then once again here we have that 0, so the reciprocal is undefined. So looking at this graph, how do we connect our dots? What do we do?
Make go all the way up.
If you think about these points right here, for instance, this point right here would be 1/2 for a height, right? What would be the reciprocal of 1/2?
2.
Be up here at 2. Okay? As you get closer and closer to 0, you're at 1/100th. The reciprocal of 1 over 100 would be 100. So what we see with the cosecant graph is we see a graph that kind of looks almost like our quadratic graph, but it's not quadratic because it's going to go kind of straight up here. It's not going to keep going outward. And then over here, what do you notice with those sign values instead of over here? And it's negative, so it's just going to be downward. And then once again, this would start up here and it would have this values. So the way we graph cosecant is it starts with an undefined. Then we have an upward U shape. Then we have an undefined, a downward U shape, and then an undefined. And it's just going to keep repeating, up, undefined, down, so on and so forth. What did you notice the period length? Same as sine. So everything you find is exactly the same. Amplitude. Amplitude tells us this point. If the amplitude was 2, it means this point would be up 2 and it would be going up here. You just have to remember, what does the curve start with and how does it look? Okay? So there's our cosecant graph. Now, y equals cosine x. Okay, so once again, start at 1, -1. We have our pi halves, pi, 3 pi halves, 2 pi. Okay. You guys said start at the 1, 0, -0, then back up, right? Okay, so we're seeing that basic curve here. So y equals secant x. Just like cosecant was up here. Cosine and secant are the reciprocal functions, and they're going to mirror kind of the same way. When you have your amplitude, you're there. Zeros are undefined. We have our negative. Vertical asymptote, and then there. So we see that secant starts with kind of this halfward upward shape here. Because once again, the cosine 0 was right here, so that's that vertical asymptote. Then we see a stretch here, and then back up here. Very similar to the cosecant, right? So remember, cosecant starts with an asymptote, secant starts with that amplitude. And once again, the positive amplitude here would be that upward trend. If this was a negative amplitude here, then we would start down here, basically. Just be that x-axis reflection then. Does that make sense? And then we're going to start just shifting them around, kind of making them wider and stuff. That's it. Once you know the basic ones here. Now, let's talk about tangent. Tangent has some change. Okay? Tangent amplitudes tell us a curvature. Okay? It's not going to tell us a stopping point like sine, cosine, secant, cosecant, where there's kind of a cut line. We will be going through the amplitudes, but they tell us how the lines curve. Okay, so A tells us that amplitude, but it's a curved amplitude. It's telling us a curvature. Okay. B I don't know back here. How many cycles from 0 to pi. Okay? Which means a period equals pi divided by b versus the 2 pi. Okay? And then once again, our H and K's, the horizontal and our phase shifts, and then our vertical shifts, kind of similar in there. But these are going to be the main two things. Okay? So that A and that B. Now, so you're well aware, okay, I am going to make a disaster on this graph. Okay? By relating the relationship that we've already talked about as tangent is sine divided by cosine. Okay? If you remember, tangent was y over x. Y was the sine on the unit circle. X was the cosine on that unit circle. Okay, so tangent has this relationship. So we have our 1, -1, pi halves, pi, 3 pi halves, 2 pi. Okay? Let's see here. We'll use, so sine's going to be pink. I'm just going to kind of go like this and put a little pink on that sign there. Remember, sine started 0, went up, down. We have this nice curve looking like this. Right? Cosine. I'll put some yellow over it. Cosine started up here. So we see we have a graph looking like this. Okay? Probably seen graphs like this before, right? With this double. Your double helix in your science world with your genetic strains and stuff. Or strands, I should say, not strains, strands. Kind of looks like that, right? Now, what we're going to use is we're going to use the properties of this to graph our tangent function. Okay? Here we're going to take sine divided by cosine. So if I look right here, sine is 0, cosine is 1. What's 0 divided by 1?
0.
0. So if you notice, tangent starts with a 0. Now, at pi halves, what happens at pi halves? We got 1 divided by 0, right? So that's that undefined. And then what happens at pi here? 0 divided by -1, right? Which would be 0. Here we got -1 divided by 0, so once again undefined. And then a 0. Now, I want you to look right here. Halfway in between 0 and pi halves. What do you notice happens here?
1.
We get an intersection, right? We get the same value. What's something divided by itself?
1.
1. Now over here, we would see we'd have a positive value divided by a negative value, so we'd have a -1. And then here, we'd have a negative value divided by a negative value, which would tell us then a positive value. Okay, so what we're thinking about here is we're thinking about, like, let's just say, for instance, this is 2/3. It's not 2/3, but let's just say the value here would be 2/3. Okay, it looks about 2/3 up on my graph, but granted, these are hand-drawn graphs, so they're not perfect. Okay, so 2/3 divided by 2/3 is 1.
I got that.
Okay, over here, I would have a positive 2/3 right here. So if I'm going right in between here, I'd have a positive 2/3. Here I would have a negative 2/3. So a positive 2/3 divided by a negative 2/3 would be a negative 1. Here I would have that negative 2/3 divided by a negative 2/3, thus positive 1. Does that make better sense now? And then over here, once again, I'm seeing kind of a repeat, this high, this negative right here, or positive value here, and then the negative here, so I'm going to see that negative 1. So the tangent curve is very similar to our cubic function polynomial curve, where we're kind of coming up and curving right here, but we're seeing a repeat in this curve. We're seeing a repeat in this curve as we keep going over. So if you notice, a 0 goes up, and then I go up, and then wait, this part is repeating this part right here, correct?
Yeah.
So that means tangent has that period of pi length. Okay, so we don't go out to 2 pi. We only have to graph tangent to pi before we start repeating that curvature. Okay, so we basically notice that right here, okay, is where we get one full cycle. We have this upward, and then we get this upward repeats right there. Okay, so this is our tangent curve graph right there. Now, if you notice, the critical values we label on tangent. Once again, remember to find your labels on here. We take our period, pi, and divide it by 4. So pi fourths, pi halves, 3 pi fourths, then to pi. We're labeling the zeros, the amplitudes for that curvature, and the asymptotes. Kind of like we did with secant and cosecant. Makes sense, somewhat? Okay. Now, cotangent. Once again, just to reiterate the tangent function and to show you how the tangent and cotangent graphs are reciprocals of each other, we're going to just graph one cycle of our tangent function. So remember that tangent function had an amplitude of 1, negative 1 for our graphing purpose. From 0 to pi was one cycle. So basically every pi fourths was what we're working with. So rather than going by pi halves, pi, 3 pi halves, 2 pi, because remember cosine and sine went out to 2 pi, tangent only goes to pi for one cycle. So we got to break 0 to pi down into 4 parts. So we take pi and divide it by 4.
Why you finishing by?
What? Because tangent cycle starts repeating at pi, not 2 pi like sine and cosine. Okay, so that's one thing you have to relate the difference for the period is pi divided by b versus 2 pi. Now, remember, tangent started with the 0, went upward because it followed the sine function for the values. Then went to a 0, or an undefined, because cosine goes to undefined here. And then we had this break, or then we start negatively and go here, so we're seeing this graph like this. Now, that's we have to disagree. Okay, y equals cotangent x. Now, cotangent is a reciprocal of tangent. So in a way, it relates to cosine x over sine x. But we're just going to relate to the function right here. As we consider this, what's the reciprocal of 0?
Undefined.
Undefined. So cotangent starts undefined from that 0. Then what's the reciprocal of 1?
1.
1. What's the reciprocal of undefined?
0.
0. Reciprocal of negative 1? Negative 1. And then once again we got the 0 here. So we have our undefined. And connecting our dots, what we see with the cotangent graph is the tangent graph goes upward, the cotangent graph goes downward.
How you get the points?
What?
How you get the points for unit to points?
Cotangent starts undefined.
Yeah.
This is the amplitude. This is a 0, this is an amplitude, and then goes here. And just remembering that cotangent is going to go downward when it's a positive
And if it's
value there.
negative?
And if it's negative, it's going to go upward. If this was a negative cotangent here, then we would look like the tangent graph just shifted over. Okay, so the main part of this is you really have to understand how these trig functions just kind of look overall and how do they start. What critical values do we use? Okay. I made it pretty by using colors. Hopefully that helps out somewhat. But we'll get into it and see what we can do now. So, number 2. Number 2 says g of x equals 3 tangent x. It tells us to graph one period of the function, and it says describe the transformation of the graph from its parent function. So basically what you have to remember is for all these graphs, we have a whole bunch of things going on. Many different things happening. I'm going to check one thing here because I don't think I make it that hard for you. Put it that way. Yep. On all of these graphs, today the secant, cosecant, tangent, cotangent, I have no phase shifts or vertical shifts for you. Okay, we'll cover that in pre-calculus class. Okay, so basically you've got to worry about the period and the amplitude for graphing for right now and what the curves look like. So we have an amplitude of 3. What's our period here?
Should be.
Just pi. Remember, tangent is pi divided by b. Okay, that's the change in the formulas here. Okay, so that's the one thing you got to remember out here. So now we're going to go and graph this. Please remember, to find the points we're going to graph, we're going to take our period, so these critical values, take that period and divide it by 4. So we start at 0, 0 plus pi fourths, plus pi fourths, plus pi fourths, plus pi fourths. Okay, and this works for every single, where you start at, take that period, divide it by 4. Whatever you're working with, it's going to tell us how we're going to graph this. Okay, now, what's our amplitude? 3, right? So I can go 1, 2, 3. -1, -2, -3. How does tangent start? At a 0. Then tangent's going to do what? Amplitude. Then undefined. Negative amplitude, and then 0. Now, please remember, these curves are a little hard to draw, but you do have to kind of understand the curvature. It is basically an upward curve that kind of levels and then comes up like this. Okay, so we have this. We're just seeing it's going up faster. Before, it would have kind of came over and then up. Okay? Got a little bit off there, okay? So we see we have our graph like this. Don't go kind of up and then over and then there. It's almost like a quadratic curve, okay? That half of it, kind of that half kind of downward in there type thing. Okay, just trying to explain things so you get kind of close to what that curvature is looking like in there. So basically what happened here is we had a vertical stretch factor of 3. The original one would have had an amplitude of 1 here, and we just stretched it up to 3. We just made that graph taller, so that's the description. The amplitude is a vertical stretch factor. Number 4. 4 says g of x equals cotangent of 2x. So amplitude equals 1. Period equals pi halves. Remember, cotangent goes with tangent. So pi divided by b, so b is 2 here. So what are the critical values going to be at then? Take pi halves, divide it by 4. So pi eighths or 1/8 pi. So if I'm going up 1, down 1 for my amplitude, pi eighths, pi fourths, 3 pi eighths, pi halves. All I'm doing is I'm starting at 0 and adding my pi eighths, add pi eighths, add pi eighths, add pi eighths. If you notice pi halves, so here to there, should have one full thing going on there. How does cotangent start? What? Undefined. So cotangent has that undefined it's starting with. So we have that vertical asymptote. Then what's cotangent going to do? Amplitude, 0, negative, undefined. So we have this downward curve for our cotangent.
Oh, you know you need to do the other line in by 2.
Pi halves,
Yeah.
because where we start, we have to end.
Okay.
So we start undefined, we have to end undefined. That kind of ends one full cycle then. Making sense?
Yeah.
It's just remembering how things start, kind of what to do in there, but nothing's really changing from our other ones. For amplitude, the period changed the formula there a little bit, instead of 2 pi, it's pi. But the critical values and just knowing where to plot those points is the biggest thing. Once you have this kind of down, it's just change numbers, and repeat. So let's go to 14. 14 says g of x equals 2 cosecant x. So, amplitude, 2, period, 2 pi. Remember, cosecant goes with sine, so it's 2 pi divided by b. b is 1 here, so we got 2 pi. Now, on this part, we're going to take our critical values, or 2 pi divided by 4, right, which is every pi halves. So we have our 2, negative 2. Once again, pi halves, pi, 3 pi halves, 2 pi. How does cosecant start? Undefined. Remember, think about cosecant relates to sine. Sine starts at 0, so reciprocal would be undefined. Then what would we do? The upward. Undefined. Downward. Undefined. Okay? Make sense? Do okay?
Yeah.
Somewhat? Maybe?
Yeah.
Like I say, take a little practice. 18. 18 just looks like a fun one. G of x equals, here they go, 1/4 secant of 2 pi x. Now, here's the nice part about us graphing by hand and not with a calculator. Okay? If you notice, this mark right here was about the same mark distance I did for all our other ones when I put a 1 right there, right? So, I mean, really, we could use almost the same graph for everything. It's just what you label on the graph matters. That's why I have you label everything that we're using. Because you could stretch things, you can even think of a picture, you can zoom in, zoom out, whatever's going on here. So when I do this one right here, and I look at this, what's the amplitude? 1/4. So I can go like this, I'm going to go up 1/4, I'm going to go down 1/4. I just say, oh, this tick mark's 1/4 now. Now I could put a tick mark 1 here and then go, 1/4 is right there. But that gets really small on that graph. Purpose is to kind of know the overall features of this and how to interpret what's going on. Not all the precision in there. We want a little precision, but it doesn't have to be perfect. Now, what's my period going to
Pi
be?
divided 2 pi.
So 2 pi divided by 2 pi is 1. Okay? So that means I'm going to take 1 and divide it by 4 for my critical values. Now, if you notice, 1/4 is the y distance from here to here. The x distance is also going to be 1/4. This is the same distance. Okay, so it's always nice to have some features be close to the same. So we got 1/2, 3/4, and then 1. Please remember when we use like pi halves, like back here, pi halves, this is just saying 1.57. This is stating 3.14. Okay, it's just that pi value could be divided out and everything will work with there. They're just numbers. How does secant start?
1/4.
At the 1/4. Then we'll go to undefined,
Negative 1/4.
negative, undefined, 1/4. So we see we have kind of this upward curve right here, and this downward curve right here. Now, I will tell you, here are some of the issues. Here are some of the issues, especially some of you found out checking answers with back of the book. They don't always start at 0 and just move to the right. They move both directions. So what you're going to see in the book is they're probably going to have a negative 1/4 here and have a graph looking like this, and that's going to be their answer. Okay? I found over the years that when I go both directions, I understand it, but many of you will not and start getting confused. So I will always just start at the 0 and move to the right. Okay? But remember, all these graphs can go both directions, to the left and to the right. So reference kind of, does this point match up that stuff? And also, many a times when you see graphs, especially on the graphing calculators, these asymptote lines are not on there. All you're going to see is this curved line and this curved line. Okay? So be well aware as you're looking through things, sometimes those asymptote features are not graphed. But you got to kind of imagine those lines in there. Because really they're not part of the graph. This dotted line isn't part of the graph. But we put it there to know that, hey, we're not crossing it over. This is where we're kind of stopping at. Make sense? Seem easy? Okay, so look at 24 then. '24 gives you a graph. What graph do they give us here? What are we going to go with? Tangent. If you notice, at the y-axis, it starts on a 0. That's how tangent starts, right? What's the amplitude of tangent? 5 here. And then our period.
5.
Okay.
Negative 5.
So if you notice on this graph, I just kind of trace it out. They go 5 here, negative 5 here. They put a dotted line and they just label this as pi fourths.
Negative 5.
Okay, and then negative pi fourths. And then they go, okay, kind of in the middle here. They have this right here. Okay? How much distance do we have from this asymptote to this asymptote? Pi halves, right? So a period equals pi halves. What goes in front of the x here?
5. So, no.
B goes in front of the x, right?
2.
Remember, the period equals pi divided by b. So in this case, it works out great because we got pi over 2, so it matches. Oh, it's just 2 right here. But remember, if this doesn't match up nicely, the period equals pi divided by b, so you could cross multiply and solve for b if you had to.
You could also just swap the graphs and multiply.
Okay, easiest way would be to look at, here's the period, pi halves total, from asymptote to asymptote. Remember, we go 0 to 0, whatever it is, that's always the same distance. One cycle is one cycle, that's that period. Considering that, once again, remember pi halves equals that period of pi divided by b, so then he's got to solve for b in that proportion. This way, when these numbers aren't just pi divided by a number here, you can work with whatever you need to. Okay? But once again, do realize the book gave us tangent as going both directions versus just starting here and moving over. So pay attention to those values. Okay, last thing, 36. Here they asked us to do a vertical stretch of 2 and an x-axis reflection. What does the vertical stretch factor do?
A 4.
It's multiplying by 2, right? Remember, the vertical stretch factor in any part here talks about the a on our trig function, right? What does the x-axis reflection tell us? Remember what the x-axis reflection was?
Negative b, or negative x.
Negative in front of that trig function. Okay? So basically we're saying we're going to multiply this by 2 and then take the negative, or multiply by a negative 2. So f of x equals negative 8 cosecant x. Oh. Sorry, g of x. They told us to do the g of x.
Every time it's going to be negative when it's in XA.
X-axis reflection is the negative amplitude. Okay? So homework! 1 through 33 odd. 16 will be the one I'm going to grade. So 1 through 33 odd, 16 will be the one I'm going to grade.